Query number 2. The table below lists the number of students enrolled in 5 different statistics courses offered by the university. We are being asked to calculate the mean number of students per class. So mean is average. We simply have to add the observations that we have. So we have 22, 20, 18, 22, 25 up to the last number 15 divided by the number of observations. In this case, we have 5 observations. So the order really doesn't matter. So the mean is given by summation of x over n. This is a population mean, so we're getting 21.2. What happens if we have observations that have different signs? The same will give us our answer. When we get a negative, it is a decrease in this equation. So the question here is asking, the following are the daily percentage in terms of increase or decrease of stock prices over a 5-day period. So what is the mean? So here we're going to add these ones as they are, then we divide by 5. So we're going to have 12. We're going to 0.018 plus negative 0.286 plus. So when we add these ones here, we divide by 2. So our mean is simply summation of x over n. So what do we get when we sum up that? The concept is same. When we sum up that, we get negative 0.088 divided by 5. Negative 0.88 divided by 5. Zero 0.008 divided by 5. So our average in this case will give us negative 0.0176. Negative 0.0176. The idea is you can have negatives and a negative what? Mean. Okay. Then we have a data set that has daily demand for 7-day period from day 4 to day 10. And we're being asked to calculate the forecast for January 11. So we're also told that it uses the previous 3 to estimate the next forecast. So when we count these 3, we get a total of 88. The total of 88 we divided by the 3. The forecast for January 11 will be 29.3. So it's a moving average. 29.3 is our forecast for January 11. Now assume the store calculates demand every day based on previous 3 days. Based on the given data, which one is the most and least accurate? So we're going to simulate each of these ones here. So if we're going to start with the first 3, so our first forecast will be for January 7. So when we average them, we add these 3 and divide by 3, we're going to get our first forecast will be 18.3. 18.3. And we also go to the next 3. I'll start from 23. The next 3 here, 23, 14, they give us our next forecast, which is what? They give us 17.3. You're going to have 17.3. Then we get the next forecast for the next 3 from 14 to 25. It will give us a forecast for the next figure, it will be 18 exactly. That's 18. And finally, from 15 to 34, we'll get the total, and the forecast from 15 to 34 will be 24.6. 24.6. So to find the most accurate, the one that has the least variation, 15 minus 18.3, what is the variation? 3.3. 17.3 minus 25, 7.7. 18 minus 34, 16. And 1 minus 24.6. The variation here we are getting is 4.4. So you identify two critical values. So one with the highest error, this is the least in terms of accuracy. The one with the smallest error, which is the most accurate. So the most accurate forecast would be January 7. The least accurate would be January 9, because there's a bigger error term. Bigger error term. Are we following? So now let's go to our next question. The table shows the scores of 9 students. We're being asked to find the median. So we first rearrange from the smallest, 71, to the highest, 96. When we rearrange them, we understand that the median is half of n. So our sample size is 9. Half of 9 is 4.5. 4.5 when you round up is a fifth term. So the fifth term in this case, we're going to count manually 1, 2, 3, 4, 5. So 85 therefore becomes our fifth term, the median. So 85 is our median. And we also have the data set here for an 11-day period. And we're asked to find the median. So we first rearrange as we did. Median is half of n. 11 is 5.5. 5.5 we round off is a 60th term. 1, 2, 3, 4, 5, 6. So 69 is our 60th term, which is a median. That is how we calculate the median. Then we have data which is arrayed as follows. So we have a company that asks the customers to rate their services from 1 to 100, and we had 4 recordings or ratings, 24. So we're being asked in this question to identify the mid-range. Mid-range is simply the highest value plus the lowest value divided by 2. So in this case, when you scan through, the highest value is 96. And the lowest value when you scan through is 62. So when you add these two and divide by 2, our mid-range will be 79. That is how we calculate the mid-range. Question number 7. We are told that the daily demand for hammers in the hardware over a 20-day period is given as follows. So if you go here, we have numbers 0 up to 4. You enlist them, those are your values of x. So how many zeros do we have? We have 1, 2, 3, 4. You can even put a tally if you want here. 1, 2, 3, 4. How many ones do we have? We have 1, 2. So we have 1, 2. How many twos do we have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And how many threes do we have? 1, 2, 3, 4. 1, 2, 3, 4. And how many fours do we have? 1, 2, 3. 1, 2, 3. So these are our. But to find the frequency distribution, just calculate this as a frequency. Sometimes we ask to find the relative frequency. We divide this divided by the total. 0.2, 0.1, 0.35, 0.2, and 0.15. Then we asked to find the relative cumulative frequency. We bring this guy here. 0.2 comes there. We add to 0.1, we get 0.3. Add to 0.35, we get 0.65. We add to 0.2, we get 0.85. And we add to 0.15, which is 1.00. If you ask to calculate the cumulative frequency just as it is, we start with the 4, add to the 2, we get 6, add to the 7, we get 13, add to the 4, we get 17, add to the 3, we get 20. So this is how the frequency distribution table can be done. A grocery store records the time in minutes required to check out 9 randomly selected customers. Identify the mode. So when we go here, we have 1s up to 5. 1 up to 5. How many 1s we have? We have 1, 1. How many 2s do we have? We have 1, 2. How many 3s do we have? We have 1, 3. How many 4s we have? We have 1, 2, 3, 4s. How many 5s we have? 1, 2, 3, 5s. So our mode is the highest mode that is appearing. So this we have 4 and 5. So this is a bimodal frequency. If there are more than 2, it is multimodal. So if all of them were 1s throughout, there'll be no mode at all. All of them were 1s, there'll be no mode at all. But given a data set of 11 US cities in 2007, identify the 60th percentile. So the first thing, you rearrange the data. So to calculate the 65th percentile, 0.65 times, how many are there? 11. We get 7.15. If I say you round off, round up. So this is like the 80th number. 80th number. So after rearranging this, the 80th number will be because this is not rearranged, we need to rearrange it. So the 80th number, after you arrange it, you find is 2.21. If you're going to rearrange this data in ascending order, 2.21. The same principle here occurs when you are given 32 observations and you're asked to find the 15th percentile. So just calculate 0.15 times what? 32. We're going to get 4.8. So whatever decimal point you have to round up. So you're looking for the 5th term. You're looking for the 5th term. So fortunately, this data here is already rearranged. 1, 2, 3, 4, 5. So our 5th term in this case is what? 263. That is our 5th term. I hope we're following, we're moving together. Question number 11.
Yes.
It has 15 adults. We are asked to calculate the percentile rank with the 126 symbiotic pressure. Now this is interesting. It has 15 adults. N is what? 15. So we're going to look at what percentile is represented by 126 of this figure there. So firstly, we need to arrange it in the order from the lowest to the highest. So we identify the position that 126 has. Then, since there are, we count the number of elements that are below this 126. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of the total, which is 15. Then we calculate the percentage. That is how we get the percentile. I repeat, you have to rearrange the data in ascending order and identify the number you're looking for, the n observations. So the number of observations you have on the left, formulas will ask you to add a +1, then over the total elements that you have. So this is like working in reverse. So this is the number of observations, you add a 0.5 over 15, then the percentile. So the 11 this side plus 0.5 over 15 times 100 is giving you about 76.7%. That is a percentile. So the 0.5 is simply a correction term. It's part of the formula. Suppose we ask to find the percentile of 114. So 114 is here. How many numbers are before 114? 1, 2, 3. So that put 3 over 15. Then you add a 0.5 to this figure, which is standard. So 3.5 out of 15, then you get the percent. Is that clear?
Yes.
All right. We have question number 4, where we are told that the statistics professor administered an exam to 3 different classes, one at 8, each had 20 students. So you can have 20 students that are 8. So the average score, you call it the frequency, was what? 82.4. And we had another test which had 24 students at 9, which had an average of what? 78.9. And finally, the 9 students with an average of what? Of 87.3. We're being asked to find the overall average for all the 3 classes combined. So to multiply this is not a problem. Okay, the total we're going to get here is 73.3. But out of which total? Out of which total? People make a mistake, either to get the total here or the total here. So the question is, you have to swap. So this 2024, this is the number of students. This 82, 78 is the average score. So if they're asking you to find the average number of students, the average number of students, you use the average for the what? The total for the score. But if they ask you to find the average score, you use the total for the number of students. So this number of students is 73. So you're going to divide this by 73. So 73 over 73, we get 83.2. So this is the average overall score. That's how it goes. You swap the idea. Let's get the idea again here. We have 3 grades A, B, and C, which correspond to points 3, 2, and 1. So here we want to calculate the average students point per semester. So again, I said you can understand that A corresponds to what? 4. B corresponds to 3. And C corresponds to 2. So we're going to multiply 3 times 4 is 12. 3 times 2 is 6. 4 times 4, 16. 4 times 3 is 12. When we add this, we get 46. Now let's do the swap. They're asking us to find the students' what? Average grade. So if you're looking for the average grade, you get the total for the credit hours here. 3 plus 3, 6 plus 4, 10 plus 4, 14. We divide it by 14 here. If they're asking you to find the average grade, we would have gotten the so you get the swap, the difference in the swap. Are we getting?
I'm lost. I didn't understand this part.
So I'm saying getting the total is not a problem here. I just need to understand that if you're asked to find the average credit hours, you're not going to divide this by the total credit hours. You're going to divide this by the total grade total. Here, the grade total is 4 plus 4, 8. 8 plus 2, 12. 12 plus 3 is what? 13. We have divided this by 13 if they're asking us to find the average credit hours. If they're asking you to find the average grade point, instead of getting the total for the grade, you get the total for the other guy of the credit hours, 14. That's the reason why we're dividing by 14 here, because this is how it goes. You swap the total. Are we together? All right. Similarly, a 6-year-old company surveyed employees, determine how long each person worked there. The table shows the average. So look here, we're going to multiply each of these ones here. When you see such a table and you are being asked for the average, just get what I'm just saying. Average this is 5, this is 14, this is 30, this is 32, this is 60, and this is 18. The total here is giving us 159. So find the average length of time. Can somebody guess? What are we going to divide this? Because here the total, this is length of time, this is 1 plus, this is 3, 6, 10, 21. And here we're getting 10, 30, 40, 45. So help me from what I've explained. We're being asked to calculate the length of time. What are we going to divide this 159 with? By 21 or by 45?
By 21.
By 21.
By 21.
Yeah.
Because this is length of time. This is time. Length of time is 21. So we're being asked to calculate the length of time. So are we going to divide this by 21 or by 45?
By 21. By 45.
By 45.
By 45.
Yes. Why by 45? You get the correct opposite. You swap them. If they're asking you to find the average of the number of employees, would have divided by the sum total of the other subject by 21. Okay, let's go to another similar question. Okay, anyway, we're given the following table showing category of employees and their ages. So this is that. So we're being asked to find the mean. So this is group data. The mean, you find the midpoint here. What is the midpoint here? 22. So X here is what? 22. 7, 32, 87, 42, 47. So when you apply these ones, we get our frequency of X. So we know that the mean for group data is given by summation of the frequency of X divided by N. And like the same principle says, if we're looking at the average age, we divide by the total of this other guy, the total here. So the total here, when we add them up here, we're going to get the total here as 8 plus 37 plus. So this total here is 155. So multiply this by that, this by that, this by that, this by that. Total here we're going to get is 53, 55. The total here, if you want, you can get it 100. they're asking us the mean age. So this is at the age here. We don't use the total for the age, I use the total for the other part. So 55, 155 into 53, 55. So the mean age would be what? 34.5 years. That is our approximate age. So this is how this tutorial sheet was supposed to be answered. So I will send you homework to do just on these very questions. Unless there are any burning questions, you could ask now. This is the end of tutorial number 3. Thank you for your time.